Okay, so section 13.4, we are now going to translate from graphing lines into graphing inequalities. And our inequalities will have x and y in them. So it's not just graphing x is greater than 2. All right, so we have some rules that we need to follow when graphing inequalities. First thing is that we're going to graph the inequality just like you would do if you were graphing an equation. Okay, so do exactly the same steps that you would do from before. You're going to find your boundary line, which is the graph that you did, and that boundary line is either going to be solid or dashed. And that really depends on your inequality symbol, whether it has an equal sign with it or not. So if it's solid, or I guess if you have something like this with an equal sign, it's going to be solid. And if you don't have the equal sign with it, it's going to be dashed. Okay, so you'll have to remember that. Then, after you figure out where your boundary line is, you have to figure out, where do you shade? Do you shade all the points above the line, or do you shade all the points below the line? And there's a couple different methods for us to use to figure that out. And we'll go through them, and you can decide which one you want to use. Okay? If you have more than one line, so maybe you are graphing a system of inequalities, your overlapping shading is where your solution lies. So where the two shadings cross over each other, all of those points would be the solution. And you can't list out all those points because it's an infinite number of points. But your solution itself is just going to be the actual graph with the shading, with the final shading of where they overlap. Okay, so I think we are ready to do a problem. So if we had to graph these two lines and figure out the solution, we have line L, which is y is less than or equal to negative x plus 3. And then we have line K, which is y is greater than 5/3 x minus 4. Okay, let's do the first one. Y is less than or equal to negative x plus 3. So if I were to pretend this was an equal sign and just graph it, I'm looking at my y-intercept and my slope. Let's do this one in blue. So we're going to go up to 1, 2, 3 for the y-intercept. And then my slope is -1, so that means I'm going to go down 1 and to the right 1. I could have also gone up 1 and to the left 1, right? Okay, so once I have that, now I'm going to, and I didn't do the computer to make the line, I'll do my best. If this is an equal sign, I'm going to make this a solid line that goes through my points. Wow, not bad. Okay. Okay, so there's that. And if I wanted to, I can shade, and I'll use my highlighter here. Use this, okay. I'm going to be shading, I have to figure out, do I shade above or below the line? And if I look at this, it says y is less than, and I call this my line. So I'm looking for all the y values that are less than my line or underneath my line. So I find the y-intercept, and I want everything that's less than it. So that means I'm going to be shading below. Okay, so I'm going to be shading this whole area. Okay, get this down here too. Okay, so there we have it. That was our first line that we graphed. The next one we're going to do, we'll do this in a different color. So y is greater than 5/3 x minus 4. So let's do this one in red. So I'm going to go down to -4. 1, 2, 3, 4. Put my point. That's my y-intercept. And my slope is 5/3. So I'm going to count up 5. 1, 2, 3, 4, 5. And move over 3. 1, 2, 3. If I wanted to, I could do it again. 1, 2, 3, 4, 5. And then 1, 2, 3, just to be sure. Okay, and then I'm going to graph this line. And notice that there's no equal sign with my inequality, so that means that this line is going to be dashed. So you know, and if you forget and you make it solid, it's really easy to just take an eraser and erase a little bit of it, right? Okay, so there's that line. And now I've got to shade in the appropriate location. So let's read off this inequality. It says y is greater than my line. So here's my y-intercept. I want all the y's that are above or greater than my line. So that means I'm shading above. So that's this whole area. Okay. So what I can see here is where it's overlapping. Basically, this whole region right here is my solution. And sometimes people don't like to, you know, shade everything here and there and look at where it overlaps, and you just want to shade the solution. That's fine. You can go ahead and do that. Or if it gets a little messy, I could take I'll take purple. And I can just say, you know what, it's this whole area right here. And just fill it all in. Okay, it's kind of up to you what you want to do. But this is going to be the solution. Okay. All right, enough of coloring. So remember how I said there's two ways that you could have figured out where to shade. I did it by just looking at the inequality sign and reading it off. But that requires your inequality to be written as y and then your inequality symbol and then everything else so that you can read it off directly. Maybe you don't like to do that. The other option is to take a test point. And the typical test point would be the origin. So you can always use the origin as long as your graph, the boundary line, doesn't pass through the origin, right? Okay, so if I took the origin, which is 0, 0, and I plugged it into the inequality, so let's do it for the blue line. Plug in 0 here, plug in 0 there, and ask yourself, is this a true statement or not? So is 0 less than or equal to 3? And that's true. So if you get a true statement when you plug in your test point, you get to shade wherever that test point is. So that's telling you to shade down below. Okay, we can do that again for the second inequality. If we plug in 0 here and 0 here, is 0 greater than -4? Well, yes, it is. So here's my test point, and for the red line, I shade up there. So if I had picked a different point, so say I had picked this point right here, which is 1, 2, 3, 4, 5. Say I picked 5, 0 and plugged that in. Is 0 greater than 25/3 minus 4? Well, no, it's not, but that's kind of a messy thing to plug in, right? What if I had plugged in up here? What if I plugged the 5 and the 0? So is 0 less than -5 plus 3? No, it's not. That's a false statement, so you can't shade where that point is. You'd have to shade on the other side. So you do whatever's comfortable. We can work on that together in class if you need to. Okay, that's it.